For an ape that just learned to walk on two legs, we developed a suspiciously advanced ability to lie to ourselves. It's called imagination, and it's the single most dangerous, calorie-intensive, and frankly absurd trait evolution ever allowed to persist. Other animals worry about predators they can see, hear, or smell. Humans, in their infinite wisdom, evolved the capacity to be terrified of a hypothetical monster under the bed, a stock market crash that hasn't happened yet, or the social judgment of people who are, themselves, too busy worrying about what we think of them. This is not a feature, it's a bug. A spectacularly inefficient piece of wetware that forces us to live simultaneously in the past, present, and a potentially infinite number of terrifying, non-existent futures. This constant simulation of reality is metabolically expensive. Our brains, at 2% of our body mass, consume 20% of our energy, much of it fueling this tireless engine of what-ifs. The critical question isn't how we got this magical gift, it's why natural selection, the ruthless accountant of the biological world, didn't immediately bankrupt the one primate that decided to spend its energy budget on pure fiction. The answer has nothing to do with art, poetry, or dreaming up a better world. It's far more brutal and pragmatic, and it began with the simple, desperate act of throwing a rock. Our journey into cognitive absurdity begins not in the brain, but in the shoulder. The human shoulder is a mess, a loose, unstable, and ridiculously flexible ball and socket joint that dislocates if you look at it funny. Compared to the robust, locked-in shoulder of a chimpanzee, built for climbing and brute force, ours seems like a pathetic downgrade. But this anatomical flaw is the key. About 2 million years ago, as our ancestor Homo erectus was being pushed out of the forests and onto the open savanna, this unstable shoulder became a weapon. It allowed for the storage and explosive release of elastic energy, turning our entire upper torso into a biological slingshot. A chimpanzee can throw an object at about 20 miles per hour. A reasonably fit human can hurl a rock at over 60, and a professional athlete can exceed 90. This wasn't just a slight improvement, it was a quantum leap in lethality. Suddenly, a small, squishy hominid could kill or maim from a distance, neutralizing the brute force advantage of larger predators and prey. It fundamentally rewired the predator-prey dynamic. But a powerful arm is useless if the brain can't aim it. Throwing a projectile at a moving target is one of the most computationally demanding tasks in the natural world. It requires a neurological revolution. To hit a moving animal with a thrown rock, the brain must perform a series of complex, near-instantaneous calculations. It has to model the target's trajectory, predict its future position, and then plot a parabolic arc for the projectile, all while factoring in wind, gravity, and the thrower's own motion. This isn't conscious calculation, it's subconscious, predictive modeling of the highest order. The brain of Homo erectus was being rewired, not for abstract thought, but for physics. It was developing a what-if engine, a simulator dedicated to one task, projecting a possible future state of the physical world. Where will the gazelle be in 1.3 seconds? If I release the stone at this angle, where will it land? This neurological hardware, forged for the single purpose of landing a stone on a skull, was the prototype for all imagination. It was the ability to detach from the immediate sensory reality and operate within a modeled, hypothetical one. This is why we can mentally rotate a 3D object in our minds, or instinctively know how to catch a ball. That same neural circuitry, designed to track a moving object through space and time, was the foundation. The brain circuits that let us predict the path of a rock were the same circuits that would eventually let us predict the consequences of our actions, the plans of our rivals, and the existence of gods. The most profound human trait began as a ballistics computer. This new predictive engine created a profound social and evolutionary ripple effect. A hominid who could accurately throw a rock was a valuable asset to a group, but a group of hominids who could coordinate their throws was an unstoppable force. This required a new level of cognition, not just modeling the future of a rock, but modeling the minds of others. The brain's what-if simulator, originally for physics, was co-opted for psychology. To hunt effectively, one hunter had to predict what the other was thinking. If I flush the deer from the bushes, will Tog know to throw his spear from the ridge? He seems distracted today. Maybe I should signal him first. This is the birth of theory of mind, the understanding that other beings have intentions, beliefs, and perspectives different from one's own. It's the ability to run a simulation of another person's brain inside your own. This cognitive leap, driven by the practical need for coordinated violence, was the software update that enabled complex social structures. It allowed for strategic planning, deception, and the formation of deep alliances. It also created paranoia, jealousy, and social anxiety. For the first time, a species was not just worried about predators, but about its reputation. We started worrying about what others were thinking, because for the first time, we could actually imagine it. We had created a social world as complex and dangerous as the physical one. And so we arrive back at the central, cruel irony of our existence. The neural architecture built to kill a distant animal with a rock became the very system that allows us to contemplate our own mortality. The ability to project a future state of the world, the arc of a stone, was scaled up. First, it modeled the minds of our hunting partners. Then it began modeling our own future. Not just the next few seconds, but minutes, days, and years. This is the origin of planning, but it's also the origin of dread. The same simulator that let us invent the seed drill also let us invent the gallows. It forced upon us the unique and terrible knowledge that we are going to die. No other animal is burdened with this certainty. A gazelle feels fear, but it does not feel existential dread. It doesn't lie awake at night contemplating the heat death of the universe. Our imagination, born from a biomechanical hack for projectile motion, became a prison of our own design. It is an engine of anxiety that runs on a constant loop of potential failures, embarrassments, and catastrophes. This is why we tell stories, create art, and invent religions. They are all coping mechanisms, elaborate fictions we build to distract our overactive predictive simulators from the one future it cannot unsee, our own inevitable end. The greatest tool for human survival is also the source of its greatest suffering. Evolution, in its blind, pragmatic march, gave us the power of gods and the anxieties of a neurotic accountant.